Welcome. In this video, I am going to talk about chi-square test for goodness of fit and f-test. In case if you are new to the channel, you should subscribe it because here you get good quality video content. In the coming months, I am going to upload videos related to your placement related courses. So let's start. Chi-square test for goodness of fit. It is one of the most important tests, and before I start problem solving, let us quickly go through it. So it is a very powerful test for testing the significance of the discrepancy between theory and experiment, and was given by Professor Karl Pearson in 1900 and is known as chi-square test for goodness of fit. It enables us to find if the deviation of the experiment from theory is just by chance or is it really due to inadequacy of the theory to fit the observed data. So what is going to happen? Let OI, where I varying from 1 to n is a set of observed or experimental frequencies, and EI is the corresponding set of expected, which is also possibly theoretical or hypothetical frequencies. Then Karl Pearson chi-square is given by, and this is how we calculate the chi-square. This is going to be our test statistics. So we take OI minus EI whole square divided by EI for all values of I from 1 to n, and then we take its summation. Here one thing that you need to note is that the sum of all the observed frequency will always be equal to the sum of all the expected frequency. And here it follows the chi-square with n minus 1 degree of freedom. Why n minus 1 degree of freedom? Because the number of observed frequencies are n and the number of expected frequencies are also n, means the total number of n data sets will be available to us. So before I move forward, let us look at this important remark. It may be noted that chi-square test depends only on the set of observed and expected frequencies and on degree of freedom. It does not make any assumption regarding to the parent population from which the observations are taken. Since chi-square does not involve any population parameter, it is termed as a statistics, so that chi-square is actually known as chi-square test statistics, and the test is known as a non-parametric test or distribution free test. So basically in this test, if you have watched the video related to t-test and z-test, you might have realized that there I was talking about a population and a sample, but in this we are not talking about population. We are getting two sets of observation. One is observed frequency, which I am representing by OI, and another is expected or theoretical frequency. So to make more sense of it, let us solve this problem. Okay, so the following figure, this is the problem number 1. The following figure shows the distribution of digits in numbers chosen at random from a telephone directory. So there are digits from 0 to 9, and the 0 is occurring 1026 times, 1 is occurring like this, and 2 is occurring this many times, and so on. 9 is occurring 853 times. So in total, all these digits from 0 to 9 are occurring 10,000 times. Now what we have to test here? So this is the observed frequency. Okay, so we have to test whether the digits may be taken to occur equally frequently in the directory. So if there are 10 digits varying from 0 to 9 and in total they are occurring 10,000 times, so theoretically if they occur equally frequently, each of them should occur how many times? Each of them should occur 10,000 by 10 times. So each of them should occur 1000 times. I hope you got this point. Sorry. that we have the numbers from 0 to 9, and I am saying that in total 10,000 times they are occurring. So on average each of them should occur 1,000 times, but this is not what we are noticing or observing. What we are observing is that they are occurring like this, means 5 is occurring 933 times, 7 is occurring 972 times. So can we assume that this difference which is being observed here, ideally each of the digits should occur 1,000 times, but they are not occurring 1,000 times, they are occurring as per the observed frequency. So can we say that they occur equally frequently, or this deviation is just because of the deviation, or just because of the randomness of the data, or can we say that actually some of the observation or some of the numbers are occurring more frequently than the other number? So how to solve this kind of problem? So here we set the null hypothesis. What is the null hypothesis? As you know, that null hypothesis is always the hypothesis of no difference, that the digit occur equally frequently in the directory. Means I will assume that all the digits occur equally frequently. So under the null hypothesis, the expected frequency of each of the digits from 0 to 9 should be 1,000 times. So how the chi-square will be calculated? To calculate chi-square, as we know the formula of chi-square, it is summation of OI minus EI square divided by EI, and where I varying from 1 to n. So we have the 10 digits here, so the n value is equal to 10 here. So this is the observed frequency. 0 is occurring 1026 times, 1 is occurring this many times, and 9 is occurring this many times. What is the expected or theoretical frequency? That each of them should occur 1,000 times. So first of all, we calculate O minus E, or OI minus EI, whatever you want to write. So here it is written O minus E, so no problem. So it is O minus E square. How it is calculated? So you see 1026 minus 1000. In case if you wish, you can create a separate column for O minus E. So that will be equal to 26, and then you take the square of 26. So it is 676, right? Then you have 1107 minus 1000, so the difference is 107, and if you take the square of it, you get this. Here you have 997 minus 1000 is equal to minus 3, and the square of minus 3 is equal to 9. So similarly, we calculate the difference O minus E for each of the data, take the square of it. Then in this column, we are going to calculate O minus E square divided by E, or OI minus EI square divided by EI. So this 676 divided by 1000, so that will give me 0.676. Then this number divided by 1000, it will give me this. 9 divided by 1000, it will give me this. So we get all these 10 values, and in the end we have to find the summation. So summation is 58.582. So this is how we have calculated the chi-square. So this is the calculated value of chi-square. Calculated chi-square here is 58.542. And what is the degree of freedom? Degree of freedom is 9, because the number of degree of freedom is 10 minus 1, 9, since we are given 10 frequencies, right? So we have to look at the chi-square value, chi-square value at 0.05 value of alpha, or 5% level of significance. In the question it is not mentioned that at what level of significance, so we are going to test it at 5% level of significance. For how many degree of freedom? For 9 degree of freedom. So in exam usually they will provide you the table, or they will give you the value directly in the question. So here I have the table for you. I don't know whether you can see it. It's a small kind of table, because it is difficult to adjust that. So we have to look at the chi-square value for 9 degree of freedom. So let me show you. So you see that in this column we have this number 9, that is 9 degree of freedom, and level of significance I am taking 5%, means 0.05. So if you see how much we are getting 16.919. So So this is the value of chi-square from the table, right? So either the table will be given, or so you can check it. It can be extended up to maybe 30 value. So here is the degree of freedom, here is the probability level of significance. Since in the question it is not mentioned, so I am taking 5% level of significance. So if I compare this with the calculated value, which is 58.542, and the tabulated value is 16.919. So since calculated chi-square is much greater than tabulated value, it is highly significant and we reject the null hypothesis. As you know that if your calculated test statistics is greater than tabulated, then you reject the null hypothesis. So in this case we conclude that digits are not uniformly distributed in the directory. It means what? That the null hypothesis was that digits are equally distributed, means each of them are occurring with equal frequency. But as per the chi-square test statistics, we are getting the value which is significantly higher than the degree of freedom, sorry, chi-square value for 9 degree of freedom. So that is why we reject the null hypothesis and we conclude that digits do not occur equally frequently. If the value would have been less than 16.919, I could have concluded that the digits occur equally frequently. I hope this question is clear. Very easy topic. Sorry. Now look at this problem. This is the question number 2. So the following table gives the number of aircraft accidents that occur during the various days of the week. Find whether the accidents are uniformly distributed over the week. So there are 7 days in a week, Sunday to Saturday. On Sunday 14 accidents happen, on Monday 16, Tuesday 8, Wednesday 12, and so on. And see, this time they already have given the chi-square value for different degree of freedom. So which test statistics I have to use, which value I have to use? We have the data for 1, 2, 3, 4, 5, 6, 7. So here n is equal to 7. So n minus 1 is equal to 6. So for 6 degree of freedom, the value that I have to use is 12.59. Okay. So what is the solution? Again, we set the null hypothesis that accidents occur uniformly over the week. As you know that null hypothesis is always the hypothesis of no difference. So even though we notice that there is a difference here, we assume that this is because of the randomness of the event. It is not because of any particular other reason. So here we set up the null hypothesis that accidents are uniformly distributed over the week. But if you have to calculate the EI, means expected number of accident, if they are uniformly distributed, so what we have to do? First we have to take the sum of all the accident. So if you take the sum of all the accident, 14 plus 16, 14 plus 16 plus 8 plus 12 plus 11 plus 9 plus 14, it is coming to be 84. And if 84 accidents are occurring in 7 days, so on average 12 accidents should occur daily. So the theoretically on Sunday 12, on Monday 12, on Tuesday 12, and so on, this number of accidents should occur. So how we will calculate the chi-square? Either we can create a table, or we can, since we have just 7 observation, we can directly calculate also. So what is the formula of chi-square? The formula of chi-square is summation of observed frequency OI minus expected frequency EI, a square of it, and divided by EI. So EI is 12 in all the cases, and observed frequencies are like 14. So I take 14 minus 12 square divided by 12. So this is the first value for first observation. For second it is 16. So 16 minus 12 whole square by 12. For the third one it is 8 minus 12 whole square by 12, and so on for the last also. So it is easy to calculate. You can take 1 by 12 common, and then you get all the values, like 14 minus 12 is 2, so 2 square is 4, and this is 16 and up to 4. So in total we are getting 50 by 12, that is equal to 4.17. So this is the calculated chi-square value. What is the tabulated chi-square value? So as I already have told you that we have to use the value 12.59 because the degree of freedom is 6. So the tabulated chi-square for 6 degree of freedom is 12.59. So we note that the tabulated value the calculated value here is less than the tabulated value, means 4.17 is less than 12.59. So we can accept the null hypothesis. So this is what it is written here, that since the calculated chi-square is much less than the tabulated value, it is highly insignificant, means the difference in the number of accidents happening over the period of 1 week is not very significant. So we say that it is insignificant and we accept the null hypothesis. Since we accept the null hypothesis, the conclusion is that the accidents are uniformly distributed over the week. So in the previous question, since we rejected the null hypothesis, we concluded that the numbers are not uniformly distributed. But here we accepted the null hypothesis, so we conclude that the accidents are equally distributed. Okay. Okay, fine. Okay, so let us take the third question. The theory predicts the proportion of beans in the 4 group ABCD should be 9:3:3:1. In an experiment among 1600 beans, the number in the 4 groups were 882, 313, 287 and 118. Does the experimental result support the theory? So this is the observed value. Observed values are 882, 313, 287 and 118. As per the theoretical assumption, the theory predicts that the observation for the different group, like for A, B, C, D, it should be in the ratio of 9:3:3:1. So the proportion of beans in the first group A. So if I ask you if this is the expected frequency EI, this is the observed frequency OI. So what should be EI? EI corresponding to 882. So actually it should be, if I calculate, total is 1600, and out of this it should be 9 by 9 plus 3 plus 3 plus 1 into 1600. Corresponding to 882. So this is how it is written. So it should be like 9 by how much is this? 9 by 16 into 1600. So it should be 900. Similarly, for the group B, it should be 3 by 16 because the sum of this is 16. I hope you understand that the ratio is this. So the actual value will be 3 by 16 into 1600. So that will be like 300. Similarly, for C, it should also be 300, and for D, it should be 100. So this is what I have written. So let me talk about the solution. So what is the null hypothesis? We set up the null hypothesis that the theory fits well into the experiment. As you know that null hypothesis is always a hypothesis of no difference. Whatever is the observation, we will assume that it is as per the theoretical kind of expectation. So we set up the null hypothesis. The theory fits well into the experiment, i.e. it means the experimental results support the theory, right? Under the null hypothesis, the expected frequencies can be computed as follows. So total number of beans is 1600. These are divided in the ratio 9:3:3:1. So corresponding to the observed value 882, the expected value should be 9 by 16 that I have already shown you into 1600, that is 900. Corresponding to the observed 313, it should be 300. Corresponding to 287 also, it should be 300 because it is 3 by 16 into 1600, and it should be 100. So the next is to calculate chi-square, that is observed minus expected square by expected. So 882 minus 900 square by 900. Now 313 minus 300 by 300. 287 minus 300 square by 300. And finally 118 minus 100 square by 100. So if you calculate all these values, this plus this plus this plus this, the value is 4.7266. So this is the calculated chi-square. Now we have to check for what is the degree of freedom. So here we have 4 different observation, because there are 4 observation, 1 2 3 4. So the degree of freedom is 4 minus 1, that is equal to 3. So tabulated chi-square for 3 degree of freedom, and I already have shown you the table, so you can verify, it is 7.815, and the calculated we have got is 4.7266. So since calculated value is less than the tabulated value, it means what? That null hypothesis is accepted at 5% level of significance, and so we conclude that there is a good correspondence between theory and experiment. Means the expected value is not much different, the observed value is not much different from the expected value, because the null hypothesis is accepted. So experimental result is matching to the theoretical expectation. Okay, I hope it is making sense. This is one of the question that I like very much, and I think I should solve this in detail. And after that I will talk about F-test. We are around 21 minutes into the video, so possibly we will be able to complete the chi-square test with the help of this problem in half an hour. So a survey of 320 families with 5 children each. So we are doing the survey among 320 families, and each of these families have 5 children, right? They are producing a lot of children, and that is why the population is growing. So how we are noticing the data? So this row shows the number of boys, and this row shows the number of girls, and this row shows the number of family. So it means we have 14 families which have 5 boys and 0 girls. We have 56 families which have 4 boys and 1 girls. We have 110 family with 3 boys and 2 girls, and so on. The question is this result consistent with the hypothesis that male and female birth are equally probable? Right. So this is something that we have to find out. Now, as what is the null hypothesis? As we is always take that null hypothesis is the hypothesis of no difference. So we are setting up the null hypothesis that data are consistent with the hypothesis of equal probability for male and female birth. Means we will assume that null hypothesis is, what is the null hypothesis? H naught, that male and female birth are equally probable, right? Means this data, but we have to verify that whether this data conforms to our expectation or not. So if a child is being born, the probability of male birth child is equal to the probability of the female birth child. So I am calling P the probability of male birth and Q as probability of female birth, and each of them is equal to 1 by 2. Now suppose I have to calculate that if there is a family with 5 children, what is the probability that it will have 0 girls and 5 boys? So I hope you remember the binomial distribution. So binomial distribution conditions are being met here, because there are 2 events, 2 outcome, a success or a failure. I am considering P the probability of male birth as a success, and Q the probability of female birth as a failure. I hope you will not take any political message from this. It is just for the mathematical computation. You can consider it other way around also, that probability of female birth, or the female birth is a success and male birth is a failure. So you should not run after me, because we have to just consider the probability of male birth, which I am calling as P 1 by 2, and probability of female birth is also equal to 1 by 2. So to find the probability that how many families, what is the probability that a family with 5 children will have all the 5 boys, means I will calculate the probability for x is equal to 5, all the 5 boys. So out of 5 boys, out of 5 children, all are boys. So do you remember the formula for binomial distribution? It is NCR P to the power R Q to the power N minus R. So if I have to calculate the probability of 5 boys, I will calculate N, that is 5 out of 5 children. 5 boys are there. P is 1 by 2, 1 by 2 to the power 5, and Q is 1 by 2, so that is 1 by 2 to the power 0. So I will get 5C5 and 1 by 2 to the power 5, because 0 and 5 will be added. So 5C5 is how much? 1, and 1 by 2 to the power 5 is 32. So I will get the probability as 1 by 32. Similarly, for probability of 4 boy child and 1 girl child, so I will calculate, it will be 5C4 1 by 2 to the power 4 and 1 by 2 to the power 1. So 5C4 is equal to 5, and then 1 by 2 to the power 5, so that will be 1 by 32. So this will be 5 by 32. Similarly, the probability for 3 boy child will be 5C3 into 1 by 2 to the power 3 into 1 by 2 to the power 2. So I hope you can see, it will be 5C3 will be 5 into 4 by 2 and into 1 by 32. So that is equal to 10. It will become 2, so 10 by 32. I hope you would know how to calculate 5C3. 5C3 is basically factorial 5 by factorial 3 into factorial 2. So 5 into 4 by 2. Similarly, I calculate probability for x is equal to 4. So that is 5C4 and into 1 by 2 to the power 4 into 1 by 2 to the power 1. So 5C4 is 5 and into 1 by 32. So that is probability is 5 by 32. And finally, we don't have the space, so I am moving to the next page. Probability for sorry, what I have done here, I have made a mistake. 5, 4, 3, then I wanted to calculate for 2 here, sorry. So 5C2, so I will write 5C2, and 5C2 will be how much? It will be 5 into 4 by 2 into 1. So it will be 10. So it will be 10 here, and 10 by 32, right? So it will not be, it will be 10 by 32. So 1 by 32, 5 by 32, 10 by 32, 10 by 32. Now on the next page, I am calculating the probability for 1 boy child. So that is 5C1, 1 by 2 to the power 1 and 1 by 2 to the power 4. In each cases, we are getting 1 by 2 to the power. Here also the need to be correction. So we have calculated 5C2, so it will be 2 here and it will be 3 here. I hope you got it. So 1 by 2 to the power 3, 1 by 2 to the power 2 will be 1 by 2 to the power 5, that is 1 by 32. So next is, in this I am calculating for x is equal to 1. So 5C1, 1 by 2 to the power 1, 1 by 2 to the power 4. So that is also 5 by 32. And finally, the probability for 0 boy child. So that is 5C0 and 1 by 2 to the power 0 and 1 by 2 to the power 5. So that will give me 1 by 32. Right. Now, the ladies and gentlemen, I have total 320 families, and the probability that a family will have 5 boy child is 1 by 32. So how many families should have 5 boy child? That will be 320 into 1 by 32. So that is what I have written, that number of families in this column, it is showing the number of families with 5 boy child, 4 boy child, 3 boy child, 2 boy child, 1 boy child and 0 boy child. So this is what I have written. You can see 14, 56, 110, 88, 40 and 12. Right. And now I am writing the expected frequency as per the binomial distribution. So out of 320 families, the probability that a family will have 5 boy child is 1 by 32. So it is 320 into 1 by 32, that is equal to 10. Then it will have 4 boy child, that is 5 by 32. So 5 by 32 into 320, so that will be equal to 50. The probability of 3 is 10 by 32, so it will be 10 by 32 into 320 is equal to 100. Probability for 2 boy child is also 10 by 32, so that will also be equal to 100. And for 1 boy child, 5 by 32, so it is equal to again 50. and it is 1 by 32, so again it is equal to 10. Those who understand the binomial distribution, actually they should be able to guess it, that it is like 10, 50, 100, 150, 10. You know, this is how the binomial distribution terms are. But anyway, I am not going into that detail. So this is the observed frequency, this is the expected frequency. Next, what we have to do, we have to calculate O minus E square. So 14 minus 10, that is 4, 4 square is 16, 56 minus 50, 6x square is 36, 110 minus 100, that is 10, 10 square is 100, 88 minus 100 minus 12, minus 12 square is 144, 40 minus 50 minus 10, minus 10 square is 100, and 12 minus 10 is 2, 2 square is 4. Then I divide each of them by expected frequency. So 16 by 10, this, 36 by 50, this, and so on. So in the end, if I take the summation, that is the chi-square value, summation of O minus E whole square by E is equal to 7.16. How many observations are there? 1, 2, 3, 4, 5, 6. So the degree of freedom is 6 minus 1, 5. And for 5 degree of freedom at 5% level of significance, the chi-square statistics value is 11.07. Here the calculated value is 7.16, which is less than 11.07. It means the null hypothesis is accepted. And since the null hypothesis is accepted, we can conclude that the probability of a girl child or a boy child being born are equal. Or we can also say that there is a equal probability for male and female birth, and that may be accepted. Right? Means people are not doing any discrimination as far as the chi-square statistics is concerned. You can do this survey in your local area to know that whether your local area is creating any problem for the female birth. Right? So this is all in the series of chi-square. Next we are going to talk about F-test. So for chi-square we have taken around half an hour. For F-test also we will take around 20 minutes. So keep watching till the very end. So what is F-test? F-test for equality of population variance. We have seen T-test earlier, and in T-test, in one of the T-test we have seen that I was testing it that whether the sample mean is equal to the population mean or not. Means single mean T-test. So based on the sample, we were estimating that whether the X bar is equal to mu or not. Here we use F-test to test that suppose we have two independent sample that I have drawn from the normal population, right? And we want to test that whether these two samples can be assumed to be taken from the same normal population with the same variance. I repeat it, that F-test is used to test that the two samples that we have, can it be assumed to have been taken from the population with same variance. So just read it, what is written here. So suppose we want to test whether the two independent sample x1, x2, xn1 and yj means y1, y2, yn2 have been drawn from the normal population with same variance, right? Say sigma square, or whether the two independent estimates of the population variance are homogeneous or not. Under the null hypothesis, that sigma x square, the population variance for the first sample that we are estimating through the first sample, and variance that we are calculating through the second sample, are they equal or not? It means the population variances are equal or not, or the two independent estimates of the population variance are homogeneous or not. So in this case, what we do, we have the test statistics that we calculate F, that is Sx square by Sy square. What is Sx square? That is the sample variance which is calculated by using the formula 1 by n1 minus 1 and summation xi minus x bar square, I varying from 1 to n, and sample variance for the second sample 1 by n2 minus 1, and here it is summation yj minus y bar square, j varying from 1 to n2. and these two are unbiased estimate for the common population variance sigma square obtained from two independent sample, and it follows the F distribution with nu1 and nu2 degree of freedom. So since we have two samples, so the degree of freedom here we take is nu1 and nu2, and nu1 is n1 minus 1 and nu2 is n2 minus 1. I will take examples to illustrate it, so don't get confused. Now suppose this is the first problem. So in one sample of 8 observations, so we have a sample whose means n1 value is 8, and sum of squares of deviation of the sample values from the sample mean was 84.4. I hope you have understood this term. Sum of the squares of deviation of the sample values from the sample mean means sum of means summation square of what? The deviation of sample values means sample values are x, deviation from what? The mean of the sample. So summation of x minus x bar square is given to be 84.4, and in the another sample of 10 observation means n2 is given to be 10, it was 102.6. So summation of y minus y bar square is 102.6. Test whether this difference is significant at 5% level, given that 5% point of f for n1 is equal to 7 and n2 is equal to 9 degree of freedom is 3.29. It is already given, means the f value for nu1. So nu1 is actually 8 minus 1 7, and nu2 is equal to 10 minus 1, that is 9 degree of freedom at 5% level of significance is equal to 3.29. Actually this is also can be seen from the table. I just want to show you. I don't know whether you can see. So on this side we have nu1, means we are looking at 5 6 for 7 it is not there. But you can see here nu1 and nu2. So from this table you can see, but actually in our exam they will be providing us the values, so we should not be worried about that. Now what we are going to do here next, so we have to test that whether we can assume that test whether this difference is significant at 5% level, given that at 5% the value is 3.29. So we already have the value that we have to compare with. So this is the information that is already given to us. So what will be the null hypothesis? One thing that you note here, that for this problem they have not given any sample mean kind of thing. They have given us this value. So it means if we want to test whether these samples have been taken from the population with same variance, so we have to apply F test. So we are using the null hypothesis H naught, that sigma x square is equal to sigma y square, which is both equal to sigma square. It means the estimate of sigma square given by the samples are homogeneous. So the test statistics is F is equal to Sx square by Sy square. Now how this Sx square is calculated? This is calculated by using this formula 1 by n1 minus 1 into summation x minus x bar square. So n1 is 8, so it is 1 by 7, 84.8, 12.057, and Sy square is 1 by n2 minus 1, so 1 by 9, 102.6, that is 11.4. One thing that we need to note here, that when we calculate this test statistics F, we always take that value in the numerator which is greater. So did you notice one thing, that here the Sx square is greater, so we are taking it to calculate F. I will write Sx square by Sy square. Right, don't make the mistake of writing 11.4 by 12.057. This is a very important point. So to calculate F, I have written Sx square by Sy square, the one which is bigger, so I got 1.057, and tabulated value of F for 7 and 9 degree of freedom is 3.29. So the calculated value is less than tabulated value, so H naught may be accepted at 5% level of significance. So it means what? That it means we can conclude that the difference is not significant at 5% level, right? Means we can conclude that this sample of 8 observation and this sample of 10 observation both have been taken from a population with same variance. Okay, we cannot say that the variance that we are observing is different. Okay, I hope it is clear. I repeat it. What is F test? F test is used that there is a population, and from this population I have taken two samples, and based on this two sample, oh, it looks like a smiley. So based on two samples we are creating a test statistics F, that is Sx square by Sy square, and we are always making sure that this Sx square is greater than Sy square. Otherwise I will write it other way around, means the one which is greater will go in the numerator. If this test statistics is less than the tabulated value, I can assume that these two samples that I am drawing are drawn from the same population, and if they are drawn from the same population means their variances are not differing significantly. Okay, so this is the first problem. Now let us look at the second problem. Two random sample gave the following result. So the sample of size 1 and size 2. The sample 1 and 2 whose size is 10 and 12, means there are 10 values in the first sample and there are 12 values in the second sample, and it is also given that their sample mean are 15 and 14. Now notice here they have provided us the sample mean, and sum of a square of deviation from mean means the sum means summation x minus x bar square is equal to 90, and summation y minus y bar square is equal to 108. Test whether the sample came from the same normal population at 5% level of significance. Now to test whether the same came from the same normal population, because the information that is available to us, we can compare both the variance as well as the sample mean, right? So we have to apply F test as well as T test. I repeat it, suppose this information is not available to us. So in this case I will just apply the F test to test whether the sample variance sigma square is equal to the sample variance sigma y square or not, right? If this information is also given, then we also have to ensure or to be more sure that whether the two samples are coming from the same population or not. So we will compare the sample mean also, and we will apply two sample T test. We have studied that, if you remember, in the previous video. And the information for F and for T is provided to us. So once I will show it to you. So what is the process here? A normal population, let me write the solution. So just a background to understand, a normal population has two parameters, namely mean and variance. To test if two independent samples have been drawn from the same normal population, what we have to test? We have to test the equality of population mean, and we have to test the equality of population variance. So the null hypothesis is that two samples have been drawn from the same normal population, means we have to test that their population means mean mu1 and mu2 are equal, and their population variance, that is sigma 1 square, is equal to sigma 2 square. Equality of means will be tested by applying T test, and equality of variance will be tested by applying F test. Since T test assumes that sigma 1 square is equal to sigma 2 square, we shall first apply F test and then we should apply the T test. I hope if you have watched the previous video, in that video I have highlighted that to apply the T test we assume that the population variance is same, right? Sigma 1 square is equal to sigma 2 square. So what is the process? Listen it very carefully. The process is I have a situation here that we have two different samples, right? We have two different sample, and for this we are given sample mean, that is x1 bar, and we have been given y1 bar. We are also given x1 minus x1 bar whole square, and we are also given y1 minus y1 bar whole square. Now we have to test that whether these two samples have been drawn from the same normal population. So what we are going to do, first we are going to apply F test to test that whether these two samples are showing us that the variance because of this sample and this sample are same, right? So for that we have to apply F test, and once F test will be accepted, means once we will prove that the variance because of the first sample and second sample are same, then we will test that whether the mean are also same. So then we have to apply the t-test, but don't make the mistake of applying the t-test first, because t-test assumes that sigma 1 square is equal to sigma 2 square. So first apply the F-test and then apply the t-test. So it is a very important point. What is the information given to us? N1 is equal to 10, N2 is equal to 12, x1 bar is 15, x2 bar is equal to 14. That is already given to us. And x1 minus x1 bar square is 90, and x2 minus x2 bar square is 108. So to apply F test, first of all we have to calculate S1 square. So formula is known, 1 by N1 minus 1 by summation x1 minus x1 bar square. So 90 by 9 is equal to 10. And S2 square is 1 by N2 minus 1, x2 minus x2 bar square. So 108 by 11, 9.82. Since S1 square is S2 square, so under null hypothesis H0, that sigma square is equal to sigma 2 square, the test statistics F is equal to S1 square by S2 square. And this follows the F distribution with 9 and 11 degree of freedom. And this is important, see, because this is a main point I want to highlight. When I am calculating F, I am writing S1 square by S2 square. So S1, the first sample has 10 observation and the second sample has 12 observation. So which value of F we have to use? We have to use F value at 10 minus 1 and 12 minus 1, means 9, 11. And if you see the information that is given, they have given us both 911 and 119 just to confuse us that which value we are using. So be very careful. The first observation is the one which is coming in the numerator here. So this should be the first value. So F value from this, that is S1 square by S2 square, is 10 by 9.82. So we are getting 1.018. And so this is the calculated F value. Tabulated F value is 2.90. So the calculated F value is less than tabulated F value. So the null hypothesis is accepted, and we conclude that the population variance are same. So hence null hypothesis of equality of variance are accepted or may be accepted. Now the equality of population variance is accepted, we can apply the t-test. So in t-test we have to test for the equality of mean. So we are assuming the null hypothesis H0, that the mean mu1 is equal to mu2. Now what is the formula for t-test? So H0 dash or is mu1 is equal to mu2, and what is the alternative hypothesis? That H1 dash is mu1 is not equal to mu2. The dash term can be ignored also, because we already have used H0 in the previous F test. So that is why we are calling it H0 dash. So you remember that test statistics T, if you remember, was x1 bar minus x2 bar divided by under root s square into 1 by n1 plus 1 by n2. So how do you calculate s square? 1 by n1 plus n2 minus 2. This we have done in the previous video. So and then summation of x1 minus x1 bar square, x2 minus x2 bar square. So 1 by total observation 10 plus 12 minus 2, so that is 20, and it is 90 plus 108, so we are getting 9.9. So the t value is x1 bar 15 minus 14 by this 9.9 into 1 by 10 plus 1 by 12. So this value is 0.742. And which degree of freedom we have to use? The degree of freedom here is 10 plus 12 minus 2, that is 20. So for 20 degree of freedom, the value is 2.086. Don't use the 22. This is just to confuse you, they have given. So for 20 degree of freedom, the value is 2.086 and the calculated t value is 0.742. So calculated t is less than the tabulated t, that is 2.086. So the null hypothesis is accepted in this case also. It means what? That we can conclude that the sample can be taken, can be regarded to be taken from the same normal population. So first we applied F-test to test the equality of population variance, sigma 1 square is equal to sigma 2 square. Then we applied t-test to test the equality of population mean, that mu1 is equal to mu2. And since the null hypothesis is accepted, we conclude that the population mean are same. It means that the sample can be regarded to be taken from the same population because their variance are also coming to be same as per the sample, and their mean both are also coming to be same. So this is how the F-test is used. So this is all about t chi-square test and F-test. I hope we already have talked about t-test, 3 types: Z-test, chi-square test and F-test. So that's all for this video. In case if you want any other video or maybe some multiple choice kind of video, you have arrived it till here, so share with all the students. Looking at the response, that how this video is received and how many students are positively responding, I will try to create another multiple choice videos also. So that, thanks for watching. Have a great day.